Welcome to This Explainer. Okay, today we are unpacking a piece of literal everyday magic that is happening right inside your pocket right now. We use it constantly, we trust it completely, but when was the last time you actually stopped to think about the sheer science and engineering making it all possible? Seriously, how does your phone know exactly where you are? Stop and really think about that for a second. I mean, there are absolutely no physical wires connecting your smartphone to the ground. There isn't someone sitting in some massive control room manually tracking your location. Yet, the second you open an app, boom, a glowing blue dot appears on your screen, pinpointing you to within a few meters anywhere on Earth. It feels like pure magic, doesn't it? Every single time you order food or book a ride across town, share your live location with a friend, or even just track that package you bought, you're relying entirely on this invisible globe-spanning system. We're talking, of course, about the Global Positioning System, or GPS. What started decades ago as a highly classified military project has completely transformed into this universal, everyday tool. It is genuinely one of the greatest engineering achievements humanity has ever pulled off. But to truly understand how it works, we actually have to leave Earth. Section 1, the eye in the sky. Zooming out into space. Let's move from the tiny screen in your hand to the massive scale of the universe. Imagine our Earth surrounded by a whole constellation of artificial satellites, constantly on the move in the dark of space. They're orbiting at a staggering 20,200 kilometers. That's roughly 12,550 miles above us. This specific altitude is known as medium Earth orbit. It's carefully chosen because at this exact height, these satellites complete exactly 2 orbits every single day, flying at about 14,000 kilometers per hour. It's this vast, perfectly choreographed network, completely out of sight, yet intensely focused on the ground below. Up in that high orbit, each of these satellites carries a really critical piece of technology, an insanely precise atomic clock. Now, an atomic clock doesn't use gears or springs. It measures the ultra-stable vibrations of atoms, like rubidium or cesium, to keep time so perfectly that it literally wouldn't lose a single second even in millions of years. And every single second of every single day, these satellites are essentially shouting out into the void. They're broadcasting 2 basic pieces of info. Hey, I am satellite number 15, and the current time is exactly down to the most precise nanosecond you can imagine. These signals are constantly beaming down toward Earth, traveling through the vacuum of space at the actual speed of light. Your phone? Well, it's basically just an antenna, quietly listening to these signals from multiple satellites all at once. Moving on to Section 2, the geometry of location, decoding the signals. Okay, now that we know what these satellites are shouting from space, let's look at the actual math. How does your phone translate these light-speed signals into your precise location? Let's break it down like a puzzle. Imagine you're standing somewhere in a massive, sprawling park. You're lost, but you have 3 friends scattered around the park who know their exact coordinates. Friend 1 calls your phone and says, "You are exactly 5 kilometers away from me." Well, okay, that's somewhat helpful, but you could be anywhere on a giant 5-kilometer circle around them. Then friend 2 calls, "You're 4 kilometers away from me." Now we're getting somewhere. Those 2 circles overlap, intersecting at exactly 2 possible locations. Finally, friend 3 calls, "You are 6 kilometers away from me." Boom. There's only one single place on the entire map where all 3 of those circles meet, and that is exactly where you are standing. That little park analogy brilliantly illustrates our core scientific principle here, trilateration. It's just the mathematical process of determining an exact location by measuring distances from 3 known points. Your phone is doing this exact same calculation every single time you open a map. But instead of calling friends in a park, it's using those satellites 20,000 kilometers above you. By comparing the exact time the satellite sent the signal with the exact time your phone received it, and knowing that the signal travels at the speed of light, your phone figures out its exact distance from the satellite. But here is where we upgrade from a 2D park to a 3D universe. Instead of drawing flat circles, your phone is actually drawing massive 3-dimensional spheres in space. When 3 of these massive spheres intersect, they narrow your location down to exactly 2 possible points. One of those points is usually floating way out in deep space, which your phone instantly rejects, and the other point? That's your exact location right here on the surface of the Earth. Section 3, the 4th dimension, the twist in the system. So, based on the 3D geometry we just talked about, 3 satellites should be enough, right? 3 spheres intersect at 2 points, discard the deep space one, and we're good to go. But wait. There is a massive engineering hurdle that actually prevents 3 satellites from being enough for your phone to work in the real world. It all comes down to keeping time. Remember, up in space, those satellites are running on those multi-million-dollar atomic clocks, flawlessly precise. But down here on Earth, the standard digital quartz clock inside your smartphone is cheap and, mathematically speaking, incredibly inaccurate. Since these signals are traveling at the speed of light, which is about 300,000 kilometers per second, light travels roughly 300 kilometers in a single microsecond. So if your phone's clock is off by even one tiny fraction of a fraction of a fraction of a microsecond, the calculated distance to the satellite is completely distorted. Your location on the map would literally be off by hundreds of miles. And here is the absolute genius of the system, the fourth satellite. In reality, your phone usually needs to lock onto a minimum of 4 satellites to find you. That fourth signal provides a critical cross-check. It allows the math in your phone to solve not just for your X, Y, and Z physical coordinates, but also for time itself. This fourth satellite corrects the tiny timing errors in your phone's cheap clock, syncing it perfectly with the atomic clocks in space. And it gets even crazier. Because the satellites are moving so fast and experiencing less gravity than we do on Earth, time actually moves differently for them. It's exactly what Albert Einstein predicted with his theory of relativity. Engineers literally have to program the system to account for relativity, or the whole thing would drift out of sync in a matter of minutes. Without this fourth satellite and these relativistic corrections, your GPS would be totally useless. But with it, your accuracy is brought right down to just a few meters. Section 4. Earthly Limits and Triumphs. Back to reality. Now, as brilliant as this space-age orbital math is, it still has to deal with the messy physical reality of our planet. You've probably been there. Your navigation app just completely loses its mind for a minute. That's because these signals from space are actually relatively weak by the time they travel 20,000 kilometers to reach us. They need a clear line of sight to the sky, so accuracy drops rapidly when you're deep inside buildings, driving through thick underground tunnels, wandering among huge city skyscrapers, or even hiking under heavy tree cover. But to compensate for these physical earthly limits, your modern smartphone uses a really clever workaround. It seamlessly combines the GPS satellite data with nearby Wi-Fi networks and local mobile cellular towers to figure out exactly where you are, even when the sky is blocked out. And this infrastructure powers way more than just finding a new coffee shop. Professional drivers, shipping fleets, and airline pilots rely on it heavily for safe, efficient navigation across the entire globe. Modern agriculture, completely transformed by it. Today's farmers use GPS to guide massive, heavy tractors with centimeter-level precision to plant crops, which drastically reduces waste and increases food production. And perhaps most importantly, emergency services depend on it every single day. When someone gets lost in the wilderness or calls for help from a totally unfamiliar road, GPS locates those people in distress rapidly, leading to countless life-saving rescues. It truly is a breathtaking engineering feat. The next time you pull up a map on your screen, take just a second to appreciate what's actually happening. Your phone is quietly reaching out to atomic clocks 20,000 kilometers out in space. It is measuring the speed of light, running complex 3D trilateration geometry, and checking its work against a fourth satellite to correct the very fabric of time itself, all while accounting for Einstein's theory of relativity. And it's doing the whole shebang in just a fraction of a second. Absolutely wild. That invisible connection between the little device in your hand and the stars above us is just one of the many everyday miracles we completely take for granted. Really makes you wonder what else is hiding in plain sight, right? So what everyday technology should we decode next? Think about it, keep exploring, and as always, keep trying to understand the incredible systems that shape our world. See you in the next explainer.